we're going to go through some more examples of ionic compounds. Before we did sodium and chlorine. In this case, we have a lithium and an oxygen. And for lithium, if you look through the periodic table, we notice that it has 1 valence electron, and for oxygen, it has 6. And so, when we have a situation where the number of valence electrons don't really kind of make it nice and neat, what we can do is we can imagine what would happen if it were to lose its valence electrons, or in oxygen's case, gain electrons. So for lithium, if it were to lose its 1 electron, valence electron, it would end up with a positive 1 charge. And for oxygen's case, if it were to gain 2 more electrons to make a full octet, then it would end up with a negative 2 charge. And the reason I'm doing this is because when we create ionic compounds, the number of metals or nonmetals to create a perfect full octet will vary based off how many valence electrons the metal or nonmetal has. So in this case, when we have an oxygen who wants to gain 2 electrons, and a lithium who can only give away 1, in this case, we're going to make these 2 values equal to each other. So what we can do is we can add a second lithium to the equation, and that will make this positive 1 charge a positive 2 charge, therefore resulting in a 2Li oxygen. And so when we're describing this ionic compound, we're going to write it just like this. Okay, let's do one more example. So in this case, we have aluminum and oxygen. And aluminum has 3 valence electrons, where oxygen, we remember, has 6 valence electrons. And remember that oxygen would end up with a negative 2 charge if it were to gain 2 electrons. But aluminum will want to give away 3 electrons. And if it were to do that, it will end up with a positive 3 charge. Okay, so if we're to think about how to balance these 2 values out, what we notice is that if we were to add 2 aluminum and 3 oxygen, that'll turn this 6 into a 6, this 3 into a 6, and this negative 2 into a 6, therefore balancing the equation out. This whole process I'm teaching you here is called ionic compound formulas. And this is going to be really important when you, This is going to be really important when you want to consider how many of one atom you need to have a perfect ionic compound. So here we go.